Introduction. Welcome back to ASP.NET Web Forms. If you're listening to this, you probably spent years building applications with this technology, and now you need to dust off those memories for an interview or perhaps a legacy project that needs your attention. Don't worry, it's like riding a bike. The concepts are still there in your head, they just need a little coaxing to come back to the surface. This audiobook is designed to be conversational. We're going to walk through web forms as if we're having a technical discussion over coffee. I'll cover the fundamentals, dig into the details that interviewers love to ask about, and connect everything to the broader ecosystem, including Windows Communication Foundation and Internet Information Services. Let's begin. Chapter 1. The Philosophy of Web Forms. Before we dive into the technical details, let's talk about why web forms exists and what problem it was trying to solve. Understanding this context will help you articulate your knowledge in interviews and demonstrate that you grasp the bigger picture. When Microsoft introduced ASP.NET Web Forms in 2002 with the first version of the .NET framework, they had a specific goal in mind: make web development feel like Windows Forms development. At the time, there was a massive population of Visual Basic developers building desktop applications. These developers understood event-driven programming. You double-click a button, you write some code that runs when someone clicks that button. Simple, intuitive, productive. Web development, however, was a different beast entirely. The web is fundamentally stateless. HTTP doesn't remember who you are between requests. Every time you click something on a web page, you're essentially starting a brand new conversation with the server. This was confusing and frustrating for developers coming from the desktop world. Web Forms solved this problem through abstraction. It created a programming model that hid the stateless nature of HTTP behind a stateful facade. You could drag a button onto a page, double-click it, and write code just like you would in a Windows application. Behind the scenes, Web Forms handled all the complexity of maintaining state across requests, managing the page lifecycle, and rendering the appropriate HTML. This abstraction was both Web Forms' greatest strength and its eventual weakness. It made developers incredibly productive, especially for line-of-business applications with lots of forms and data entry. But it also meant that developers didn't always understand what was happening under the hood. When things went wrong, and they inevitably did, debugging could be challenging. And as web applications grew more complex and client-side JavaScript became more important, the abstraction started to feel constraining rather than liberating. But here's the thing. For many applications, Web Forms was and remains a perfectly reasonable choice. Understanding its design philosophy helps you appreciate why certain things work the way they do. Chapter 2. The page lifecycle. If there's one topic that comes up in virtually every Web Forms interview, it's the page lifecycle. This is the heartbeat of any Web Forms application, and understanding it deeply will serve you well. When a request comes in for a Web Forms page, the ASP.NET Runtime creates an instance of your page class and then walks it through a series of events in a very specific order. Each event has a purpose, and knowing which event to use for which task is crucial for writing well-behaved Web Forms code. Let's walk through the lifecycle from start to finish. The first phase is called page request. This happens before the lifecycle even begins, technically. The ASP.NET Runtime determines whether the request is a new request or a postback. If it's a new request, the page needs to be compiled. If it's a postback, the page might already be cached and ready to go. Next comes start. During the start phase, page properties like request and response are set. The page also determines whether the request is a postback by checking the AsPostback property. This is your first opportunity to branch logic based on whether the user is seeing the page for the first time or coming back after clicking a button or triggering some other postback event. Then we have page initialization, which fires the init event. This is where the page's control hierarchy gets built. Each control on the page goes through its own initialization. Importantly, ViewState is not yet available during init. This makes init a good place to create dynamic controls that need to exist before ViewState restoration happens. A common interview question is about adding controls dynamically, and the answer almost always involves doing it during init. After init comes load view state. This phase only happens during postbacks. The view state that was sent to the client with the previous response gets loaded back into the controls. Each control state is restored to what it was when the page was last rendered. This is the magic that makes the page appear stateful, even though HTTP is stateless. Load postback data comes next, again, only during postbacks. If any controls implement iPostBack data handler, their posted data gets loaded. For example, if someone typed text into a text box, this is when that text gets applied to the text box controls text property. Now we arrive at the load event, probably the most commonly used event in the entire lifecycle. The page load method fires here. All controls are initialized, view state has been restored, and postback data has been applied. This is typically where you write code that needs to run on every request. The common pattern is to check is postback and only do certain things, like loading data from a database, on the initial request, not on every postback. After load comes raise postback events. If the user clicked a button, this is when the button's click event fires. If they changed a dropdown and it has auto postback enabled, the selected index changed event fires here. All those event handlers you wrote by double-clicking controls in the designer, they run during this phase. Load complete fires next, signaling that all postback event handlers have completed. Then comes pre-render, which is your last chance to make changes to controls before they're rendered to HTML. After pre-render, changes to controls will not be reflected in view state. Save view state happens next, and this is where the current state of all controls gets serialized and prepared to be sent to the client as a hidden form field. Render is when the page and all its controls emit their HTML. This doesn't actually fire as an event you can handle, it happens automatically. Each control has a render method that outputs the appropriate HTML. Finally, unload fires. This is your cleanup opportunity. Any managed resources should be released here. The page is about to be discarded, so this is your last chance to do any necessary teardown. Understanding this lifecycle is essential because so many bugs in web forms applications come from putting code in the wrong event. If you try to access a control's value during init, you'll get nothing because view state hasn't loaded yet. If you create dynamic controls during load instead of init, they won't participate properly in view state, and their values will be lost across postbacks. If you make changes to controls after pre-render, those changes won't be persisted. In interviews, you might be asked to explain why a particular bug is occurring in a code sample, and the answer often involves lifecycle timing. Being able to trace through the lifecycle and identify where something is happening at the wrong time demonstrates deep understanding of the framework. Chapter 3. View state in depth. View state is one of those features that developers either love or hate, and your opinion probably depends on how well you understood it. Let's dig into what view state actually is and how it works. At its core, view state is a mechanism for persisting page and control state across postbacks. Remember, HTTP is stateless. Every request is independent. But in web forms, controls maintain their state. If you have a grid view with data, that data persists across postbacks without you having to reload it from the database every time. View state makes this possible. Here's how it works mechanically. During the save view state phase of the page lifecycle, the page walks through its entire control tree and asks each control for its current state. This state gets serialized into a dictionary-like structure, then encoded as a base 64 string, and then dropped into a hidden form field called _viewState. When the form posts back to the server, that hidden field comes along with the request. During load viewState, the process reverses. The base 64 string is decoded, deserialized, and each control gets its state restored. ViewState stores the values of server control properties, but it doesn't store everything, only properties that have changed from their default values. This is an optimization to keep ViewState from becoming unnecessarily large. And here's a key point that trips up many developers. ViewState does not store data that's posted back from the user. That's handled by postback data. If someone types into a text box, That value comes from the posted form data, not from view state. View state stores the programmatic state of controls, things you set in code or that the control set internally. View state can also be used as a developer-accessible storage mechanism. You can add your own data to the view state dictionary by using syntax like view state equals some value. This data will persist across postbacks just like control state. It's essentially page-scoped session state, useful for values that only matter for the lifetime of the user's interaction with that particular page. There are important security considerations with view state. By default, view state is not encrypted. It's just base 64 encoded. A malicious user could decode it and see its contents. Starting with ASP.NET 2.0, view state is signed with a message authentication code to prevent tampering, but it's still readable. If you need to store sensitive data in view state, you should enable encryption by setting the view state encryption mode in your configuration. Machine keys play a role here. The signing and encryption of view state relies on machine keys configured on the server. In a web farm scenario where requests might be handled by different servers, all servers need to have the same machine key configured. Otherwise, a view state generated by one server can't be validated by another server, resulting in errors. This is a common gotcha in deployment scenarios. View state bloat is a real problem in large applications. A page with many controls, especially data-heavy controls like grid views, can end up with enormous view state. I've seen pages where the view state hidden field was larger than the visible content of the page. This increases bandwidth usage, slows down page loads, and can cause problems with request size limits. There are several strategies for managing view state size. You can disable view state on individual controls that don't need it by setting Enable View State to false. You can disable it for entire pages or even the whole application. You can use control state for the essential state that controls need to function, which is separate from view state and can't be disabled by developers. Starting with ASP.NET 4.0, there's a view state mode property that gives you more granular control. You can disable view state by default and then enable it only for specific controls that need it. Another approach is storing view state on the server rather than sending it to the client. Instead of putting the entire serialized state in the hidden field, you put just an identifier, and the actual state gets stored in session state or a database. This reduces bandwidth, but increases server memory usage and adds complexity. Various third-party solutions and custom implementations exist for this approach. For interviews, be prepared to explain how view state works, what it stores, how to manage its size, and the security implications. You might be asked to diagnose a problem where view state is unexpectedly large or where data isn't persisting correctly across postbacks. Chapter 4. State Management Options. View state is just one of several state management options available in ASP.NET. Let's survey the full landscape because understanding when to use each option is important for making good architectural decisions. We've already covered view state, which is page-scoped and persists across postbacks, but not across page navigations. Hidden fields are a simpler, lower-level alternative to view state. You can drop hidden field controls on your page and use them to store arbitrary values that survive postbacks. Unlike view state, there's no serialization infrastructure. You're dealing directly with string values. Hidden fields are appropriate for simple, string-based data that doesn't need the structure view state provides. Control state is a special form of server-side state that controls can use for essential functionality. Unlike view state, control state cannot be disabled by page developers. This ensures that controls always have access to the state they need to function correctly. As a control developer, you'd use control state for the minimum state necessary for your control to work. As a page developer, you generally don't interact with control state directly. Cookies store data on the client in small text files. They persist across sessions, making them useful for remembering user preferences or maintaining authentication tokens. Cookies have size limits, typically around 4 kilobytes per cookie, and they're sent with every request to the domain that set them, so they're not appropriate for large amounts of data. There are also security and privacy considerations. Cookies can be intercepted in transit if you're not using HTTPS, and users can disable or delete them. Query strings encode data in the URL itself. This is useful for bookmarkable state. If you want users to be able to share a link that includes certain parameters, query strings are the way to go. However, query strings are visible to users, limited in length, and not appropriate for sensitive data. They're typically used for navigation parameters, search criteria, or identifiers. Session state stores data on the server, scoped to a particular user session. Unlike view state, session state persists across page navigations and can store any serializable object. Session state is identified by a session ID, which is typically stored in a cookie, but can also be embedded in URLs for cookieless scenarios. There are several session state modes. In-process mode stores session data in the memory of the web server process. It's the fastest mode, but doesn't work in web farm scenarios because session data is tied to a specific server. State server mode stores session data in a separate Windows service, allowing multiple web servers to share session state. SQL Server mode stores session data in a database, providing durability and enabling session state to survive application restarts. Custom mode lets you implement your own session state provider. Session state has configuration options for timeout, cookieless operation, and which mode to use. Understanding these options and their trade-offs is important for system design. Application state is like session state, but scoped to the entire application rather than individual users. It's useful for data that needs to be shared across all users, like cached reference data. However, application state has concurrency concerns. If multiple requests try to modify application state simultaneously, you need to handle synchronization. The application. Lock and application. Unlock methods exist for this purpose. The cache object provides a more sophisticated way to store application-wide data. Unlike simple application state, the cache supports expiration policies, dependencies, and automatic scavenging when memory is tight. If you're storing shared data that might become stale, the cache with appropriate expiration settings is usually a better choice than application state. Profile properties provide a typed, persistent way to store user-specific data. Unlike session state, profile data persists across sessions. It's built on top of the membership and profile provider model, so you configure which properties you want to track, and the framework handles storage and retrieval. This is useful for user preferences or settings that should persist indefinitely. Each of these state management options has appropriate use cases. View state for control state that needs to survive postbacks. Session state for user-specific data that needs to persist across page navigations. Cookies for client-side data that needs to survive browser restarts. Query strings for bookmarkable parameters. Cache for shared data that might become stale. Being able to discuss these options and recommend the right one for a given scenario demonstrates architectural maturity. Chapter 5. Server Controls and the Control Tree. The server control model is fundamental to web forms. Let's explore how controls work and how they form a hierarchy that represents the page structure. Every ASP.NET Web Forms page has a control tree. At the root is the page itself, which inherits from control. Beneath the page are all the controls on the page, which may have their own child controls, forming a hierarchical tree structure. When you look at your ASPX markup, you're essentially seeing a declarative representation of this control tree. Server controls are distinguished by the runOut equals server attribute. When the ASP.NET parser processes your page, it creates an instance of each server control and adds it to the control tree. Controls without runOut equals server become literal text that gets rendered as is. There are several categories of server controls. HTML server controls are the simplest. They're standard HTML elements with runOut equals server added. An input element becomes an HTML input text control. A table becomes an HTML table. These controls provide server-side access to HTML elements while rendering essentially unchanged HTML. Web server controls are higher-level abstractions. A text box control renders as an input element, but it provides a richer programming model with typed properties and events. A grid view renders as a complex HTML table with header rows, data rows, and paging controls. Web server controls generate browser-appropriate HTML and handle browser differences automatically. Validation controls provide declarative validation capabilities. Required field validator, range validator, Regular expression validator, and others let you specify validation rules in markup. They can validate both on the client with JavaScript and on the server, ensuring data integrity even if client-side validation is bypassed. User controls are reusable pieces of page UI. You create an ASCX file containing markup and code, then use it on pages like any other control. User controls are compiled on demand and can have their own properties and events. They're useful for encapsulating complex UI patterns that appear on multiple pages. Custom controls are compiled controls that you create by inheriting from existing controls or from control or web control-based classes. Unlike user controls, custom controls don't have an ASCX file. They generate their UI purely through code in the render method. Custom controls can be compiled into separate assemblies and distributed for reuse across applications. Composite controls are custom controls that contain other controls. Rather than generating HTML directly, they create and arrange child controls. This is useful when your custom control is essentially a combination of existing controls with custom behavior. Understanding the control hierarchy is important for several reasons. Events bubble up through the hierarchy. When a button inside a repeater item is clicked, the event propagates up through parent controls. This is how data controls like repeater, data list, grid view, and list view handle events from their child controls through item command events. Find control is a method for locating controls by ID within a naming container. Because of the hierarchical structure, control IDs don't have to be unique across the entire page. They just have to be unique within their naming container. Master pages, content pages, and data-bound templates each create their own naming containers. Understanding this is crucial for writing code that finds and manipulates controls dynamically. The client ID property exposes the actual HTML ID that gets rendered for a control. Because of naming containers, the client ID is often different from the ID you specified. In ASP.NET 4.0, the client ID mode property was added, giving you control over how client IDs are generated. Options include auto ID for the traditional behavior, static to use the ID exactly as specified, predictable for a middle ground that's useful in data-bound scenarios, and inherit to use the parents mode. Naming container is a property that returns the control's naming container. Controls like page, user control, and data-bound template containers are naming containers. Understanding naming containers helps you navigate the control tree correctly. For interviews, be prepared to explain the difference between HTML server controls and web server controls, how to create and use user controls versus custom controls, and how the control hierarchy affects event handling and control identification. Chapter 6. Data Binding. Data binding in web forms allows you to connect data sources to controls declaratively or programmatically. This is a crucial topic because most line-of-business applications are fundamentally about displaying and editing data. The simplest form of data binding uses the data bind method. You set a control's data source property to a data object, like a data table, data set, or any IEnumerable collection, then call data bind. The control iterates through the data and generates its UI accordingly. Repeater is the most basic data-bound control. It provides almost complete control over the rendered HTML through templates. You define header template, item template, alternating item template, separator template, and footer template. The repeater iterates through the data and renders each template appropriately. Because repeater doesn't add any HTML of its own, it's useful when you need precise control over the output. Data list is similar to repeater, but renders within a table structure. It provides additional features like selection, editing, and layout options for specifying how many columns to render. Grid view is probably the most commonly used data-bound control. It renders a table with columns that you can configure to display data, provide editing capabilities, sorting, paging, and more. Grid view can infer columns automatically from the data source, or you can define them explicitly using bound field, template field, button field, and other column types. Details view and form view display a single record at a time rather than a list. Details view renders a vertical table with one row per field. Form view uses templates, giving you complete control over the layout. Both support inserting, editing, and deleting data. List View, introduced in ASP.NET 3.5, combines the flexibility of Repeater with the features of Grid View. It uses templates for complete control over rendering while providing built-in paging, sorting, editing, and selection. Data source controls abstract the connection between data-bound controls and data stores. SQL data source connects directly to a SQL database. Object data source connects to business layer objects. Link data source works with link to SQL. Entity data source works with entity framework. These controls can handle select, insert, update, and delete operations, reducing the amount of code you need to write for basic CRUD scenarios. When using data source controls, data-bound controls can declaratively specify parameters for filtering, sorting, and paging. For example, a grid view bound to a SQL data source can enable sorting and paging without you writing any code. The data source control handles generating the appropriate SQL. However, many applications outgrow declarative data sources and use programmatic binding instead. This gives you more control, but requires more code. The pattern is typically to retrieve data in page load on non-postback requests, store it somewhere like session state if needed across postbacks, and bind it to controls. Data binding expressions allow you to embed dynamic values in templates. The classic syntax uses eval for read-only binding. The expression inside the brackets gets evaluated against the current data item. Bind provides two-way binding that can extract values during updates. The newer syntax in ASP.NET 4.5 uses item with strongly typed binding when you specify item type on the control. For complex scenarios, you often handle events from data-bound controls. Grid View fires row data-bound as each row is generated, allowing you to customize the row based on data values. It fires row command when buttons in the grid are clicked. Row editing, row updating, row deleting, and related events let you handle editing operations. Understanding the data binding model deeply, including when to use declarative versus programmatic binding, how templates work, and how to handle data control events, is essential for web forms development and likely to come up in interviews. Chapter 7. Master Pages and Themes. Master pages and themes provide consistency across your application's pages. They're essential for maintainable applications and are worth understanding thoroughly. Master pages define a common layout that multiple pages share. The master page is an ASPX file with a .master extension. It contains the common elements: header, navigation, footer, layout structure, and defines content placeholder controls where individual pages inject their content. Content pages reference a master page through the master page file attribute in the page directive. They contain content controls that correspond to content placeholders in the master page. When the page renders, the master page provides the shell and the content page fills in the placeholders. This relationship creates a nested control hierarchy. The master page's controls are the outer layer. The content page's controls are nested within the content placeholder. This affects control lookups. If you're in a content page looking for a control in the master, you need to navigate to the master first. You can access the master page from a content page through the master property. If you need strongly typed access to master page properties or methods, you can use the master type directive to specify the master page type, and the master property will return the correct type instead of the base master page class. Nested master pages are possible. A master page can itself reference another master page, creating multiple levels of layout inheritance. This is useful for large applications with varying layouts for different sections. Master pages can be specified at several levels. Individual pages can specify their master page. The web.config can specify a default master page for a folder or the entire application. Code can change the master page programmatically during the pre-init event. This is the only point in the lifecycle early enough to change the master page. Themes provide consistent styling across pages. A theme is a folder in app themes containing skin files, style sheets, and other resources. Skin files define default property values for server controls. For example, you can define that all text box controls should have a certain CSS class, or all grid views should have a particular header style. Themes can be applied at the page level through the theme or style sheet theme attributes in the page directive, or at the application level in web.config. The difference between theme and style sheet theme relates to precedence. Style sheet theme applies first, then the page's settings, then theme. So theme overrides page settings, while style sheet theme provides defaults that pages can override. Skin files have an interesting syntax. You define control elements without the runout attribute and without IDs. These definitions become templates that are applied to matching controls. You can have default skins that apply to all controls of a type, or named skins applied selectively through the skin ID property. For interviews, be prepared to explain how master pages work, the lifecycle implications of the nested control structure, how to access master page members from content pages, and the difference between theme and style sheet theme. Chapter 8: Authentication and Authorization. Security is a crucial concern for web applications, and ASP.NET provides a comprehensive framework for authentication and authorization. Let's walk through the key concepts. Authentication is about identifying who the user is. Authorization is about determining what they're allowed to do. ASP.NET supports several authentication modes. Windows authentication relies on the Windows operating system to authenticate users. The web server, typically IIS, handles the authentication handshake. By the time your code runs, the Windows identity is available through the user property. This mode is appropriate for intranet applications where users are already logged into a Windows domain. Forms authentication is the most common mode for internet-facing applications. Users enter credentials into a login page, your code validates them, and upon success, you issue an authentication cookie. Subsequent requests include this cookie, identifying the user. The cookie can be encrypted and signed to prevent tampering. The Forms Authentication class provides methods for creating and managing authentication cookies. SetAuth cookie creates a cookie for a user. Redirect from login page creates a cookie and redirects to the originally requested page. Sign out removes the cookie. The authentication cookie contains a Forms authentication ticket, which includes the username, issue date, expiration, and optional user data. The ticket is encrypted using the machine key, so it can't be forged or read by clients. Membership providers abstract the storage of user credentials. The default SQL membership provider stores users in a SQL Server database with tables created by the ASP.NET Reds EQL tool. You can use other providers or implement your own. The membership class provides methods for creating users, validating credentials, resetting passwords, and managing accounts. Role providers similarly abstract role storage. The roles class and role provider architecture let you check whether users are in particular roles. Authorization rules can then be expressed in terms of roles rather than individual users. The authorization configuration in web.config specifies who can access what. The authorization element contains allow and deny rules that reference users, roles, or special tokens like for all users and for anonymous users. You can have different authorization rules for different folders by placing web.config files with authorization sections in those folders. Login controls provide pre-built UI for common authentication scenarios. Login, login view, login status, login name, create user wizard, change password, and password recovery controls work with the membership and role providers to implement authentication flows with minimal code. Membership and role providers were the original approach in ASP.NET 2.0. Later, ASP.NET introduced the identity system with more flexibility, including support for OAuth, social logins, and claims-based authentication. For older web forms applications, you're more likely to encounter the classic membership and role provider architecture. HTTPS is essential for any authentication scheme. Without it, cookies and credentials can be intercepted in transit. The require SSL attribute on the Forms authentication configuration enforces that authentication cookies are only sent over secure connections. Cross-site request forgery protection is important for any application that uses cookies for authentication. Anti-forgery tokens should be included in forms to ensure that requests originate from your pages and not from malicious sites. While MVC has built-in anti-forgery support, in web forms you typically use viewState to tie viewState to the authenticated user, providing some protection. For interviews, be able to explain the difference between authentication and authorization, how forms authentication works, including the ticket and cookie mechanism, what membership and role providers are, and basic security concerns like HTTPS and CSRF. Chapter 9. The ASP.NET HTTP Pipeline. Understanding how requests flow through the ASP.NET pipeline is valuable for debugging, performance optimization, and implementing cross-cutting concerns. Let's trace a request from arrival to response. When a request arrives at the web server, IIS first handles it. IIS determines which application pool and worker process should handle the request based on the URL. For ASP.NET requests, IIS hands off to the ASP.NET runtime. In classic mode, IIS had distinct pipelines for static files and ASP.NET content. IIS handled static files directly. ASP.NET content went through the ASP.NET ISAPI extension. This limited what ASP.NET modules could do. They could only intercept ASP.NET requests, not all requests. Integrated mode, introduced with IIS 7, unified the pipelines. ASP.NET modules can intercept any request, including static files. The pipeline events are the same, but ASP.NET code has broader reach. Integrated mode is now the standard for modern deployments. The pipeline consists of a series of events that fire as the request progresses. HTTP modules can hook into these events to perform cross-cutting logic. HTTP handlers process specific requests and generate responses. The pipeline events in order are: begin request fires first, before any processing. Authenticate request and post-authenticate request deal with identifying the user. Authorize request and post-authorize request handle access control. Resolve request cache checks if a cached response can be served. Map request handler selects the handler for the request. Acquire request state loads session state. Post-acquire request state follows. Pre-request handler execute fires just before the handler runs. Then the handler executes. Post-request handler execute fires after. Release request state saves session state. Update request cache stores responses in the cache. End request completes the pipeline. Pre-send request headers and pre-send request content fire before output goes to the client. HTTP modules are classes that implement IHTTP module and subscribe to pipeline events. They're configured in web.config. Many built-in features are implemented as modules: authentication modules, session state module, output cache module, error handling module, and more. You can write custom modules for logging, custom authentication, URL rewriting, response filtering, and other cross-cutting concerns. HTTP handlers are classes that implement IHTTP handler and process specific types of requests. The page class itself is an HTTP handler. ASMX web services have their own handler. You can write custom handlers for special URLs or file types. Handlers are mapped to URLs through configuration or through handler mappings in IIS. The HTTP application class orchestrates the pipeline for each application. The global ASAX file is a special file that gets compiled into an HTTP application-derived class. You can handle pipeline events in global ASAX by writing methods with conventional names: application, begin request, application error, session start, and so on. Application start fires once when the application starts up. This is where you do one-time initialization, like registering routes or configuring dependency injection. Application end fires when the application shuts down. Session start and session end fire when sessions begin and end. Application error fires when unhandled exceptions occur. This is a common place to implement logging. The HTTP context object is the central object that flows through the pipeline. It provides access to the request, response, server, session, user, and other contextual information. Each request gets its own HTTP context instance. Understanding the pipeline helps you make informed decisions about where to implement functionality. Should it be a module or a handler? Which event should it hook into? How does your code interact with other modules in the pipeline? Chapter 10: Windows Communication Foundation. Let's shift gears and talk about WCF, Windows Communication Foundation. While WCF is technically separate from ASP.NET, it's often used alongside web forms applications to provide services, and it shares hosting infrastructure with ASP.NET. Understanding WCF fundamentals is valuable for any .NET developer working with distributed systems. WCF was Microsoft's unified framework for building service-oriented applications. Before WCF, there were multiple technologies for different communication scenarios: ASMX for SOAP web services, .NET Remoting for in-process or TCP communication, MSMQ for message queuing, Compus for transactions. WCF unified these under a single programming model. The core concept in WCF is the ABC: address, binding, and contract. Address is where the service lives. It's a URL, could be HTTP, TCP, named pipes, or other transports. The address specifies how clients locate the service. Binding is how the service communicates. Bindings encapsulate protocol, encoding, and transport details. Basic HTTP binding provides SOAP over HTTP, compatible with older web service consumers. WSTP binding adds WS standards like security and reliable messaging. NetTCP binding uses binary encoding over TCP for high performance between .NET clients and services. NetNamed pipe binding is for same-machine communication. NetMMMQ binding uses message queuing. There are many more, and you can create custom bindings. Contract is what the service does. Service contracts define the operations available, expressed as interfaces with the service contract attribute. Operation contracts mark individual methods with the operation contract attribute. Data contracts define the types that flow between client and service. Here's a simplified picture of how it works. You define a service contract as an interface decorated with service contract. Each method you want to expose gets the operation contract attribute. You implement that interface in a class. You host the service somewhere: IIS, a Windows service, a console app, whatever. Configuration specifies the address, binding, and contract for each endpoint. Clients generate proxies from the service's metadata and call operations through the proxy. Data contracts deserve more attention. When you pass objects across WCF, they need to be serializable in a way both sides understand. The data contract and data member attributes define how objects are serialized. Only properties marked with data member are included. This gives you explicit control over the wire format. WCF supports several hosting options. IIS hosting is convenient for HTTP services. You create a botsbc file that specifies the service implementation, and IIS handles activation. Self-hosting means running your own host, typically a Windows service or console application, giving you more control over lifetime and configuration. Windows Activation Service extends IIS hosting to non-HTTP protocols. Behaviors modify how the service or operations behave. Service behaviors apply to the service as a whole. Operation behaviors apply to individual operations. Endpoint behaviors apply to specific endpoints. Behaviors can enable things like metadata publishing, instance management, throttling, and more. Instance management controls how service instances are created. Per call creates a new instance for each operation, which is stateless and scalable but has overhead. Per session maintains an instance per client session, enabling stateful services but requiring session affinity. Single uses one instance for all clients, useful for singletons but requiring careful synchronization. Concurrency mode controls how operations handle simultaneous calls. Single means only one operation at a time. Reentrant allows callbacks during an operation. Multiple allows true parallel execution, requiring thread-safe code. Security in WCF is comprehensive. Transport security encrypts the connection, like HTTPS for HTTP transports. Message security encrypts individual messages, useful when messages pass through intermediaries. You can configure authentication, authorization, impersonation, and more through behaviors and bindings. WCF provides rich error handling through faults. Rather than exposing .NET exceptions directly, which could leak sensitive information, you define fault contracts that specify what error information clients receive. The fault exception class lets you throw strongly typed faults. For clients, you typically generate a proxy using Add Service Reference in Visual Studio or the svskutil command line tool. This reads the service's metadata, its WSDL, and generates client classes. Alternatively, you can manually create channels using Channel Factory for more control. While WCF remains supported, Microsoft has moved toward other technologies for new development. ASP.NET Web API and later ASP.NET Core provide RESTful services with simpler programming models. gRPC offers high-performance binary protocols. However, WCF is still prevalent in enterprise environments, and understanding it remains valuable. For interviews, be prepared to explain the ABC of WCF, the difference between major bindings, how contracts work, hosting options, and instance management modes. You might be asked to compare WCF to REST services or explain when you choose one over the other. Chapter 11. Internet Information Services. IIS is the web server that hosts ASP.NET applications on Windows. Understanding IIS architecture and configuration is essential for deploying and troubleshooting web forms applications. IIS has evolved significantly over the years. The modern architecture, introduced in IIS 7, is modular and extensible. Rather than a monolithic server, IIS is a core engine with functionality provided by modules that you can add or remove as needed. The key architectural components are the protocol listeners, the Windows Process Activation Service, and worker processes. Protocol listeners handle incoming network traffic. HTTP.SES is the kernel mode HTTP listener that handles HTTP and HTTPS requests. It performs initial request parsing, URL routing, and response caching at the kernel level for performance. Other listeners handle protocols like NET, TCP, or net.mmq when WCF services use non-HTTP transports. The Windows Process Activation Service, or WAS, manages application pools and worker processes. It activates worker processes when requests arrive and handles recycling and health monitoring. Worker processes, running as W3 WP TIXC, actually execute your application code. Each worker process loads the .NET runtime and the ASP.NET pipeline. Multiple worker processes can exist for different application pools, and a single application pool can have multiple worker processes for WebGarden scenarios. Application pools are a crucial isolation boundary. Each application pool runs in its own worker process with its own identity, configuration, and memory space. Applications in different pools can't affect each other. If one application crashes, it doesn't bring down applications in other pools. Application pool configuration includes the .NET runtime version, managed pipeline mode, integrated, or classic, the identity the worker process runs as, recycling settings, and process model settings like idle timeout and maximum worker processes. Recycling is an important concept. IIS can automatically restart worker processes based on various triggers: elapsed time, number of requests handled, memory usage, or a specific schedule. Recycling helps prevent problems from memory leaks or accumulated state. However, recycling drops in-process session state, so applications relying on session state need to use out-of-process providers. IIS configuration lives in several places. The application host config file in the IIS configuration directory contains server-wide settings. Web.config files in application directories contain application-specific settings. The IIS Manager GUI provides a user-friendly interface for editing these configurations. Virtual directories and applications define how URLs map to file system paths. A site is a top-level container bound to specific IP addresses, ports, and host headers. Within a site, Applications are URL prefixes that have their own application pools and configurations. Virtual directories map additional paths without creating separate applications. Handler mappings determine which handler processes requests for particular URL patterns or file extensions. By default, ASPX files go to the page handler factory, ASMX files go to the web service handler, and so on. You can add custom handler mappings for your own file types or URL patterns. Module configuration determines which HTTP modules participate in the pipeline. In integrated mode, modules configured in web. Config affect all requests. You can add custom modules or remove modules you don't need. SSL configuration is essential for secure sites. You install SSL certificates in IIS, bind them to sites on port 443, and configure HTTPS requirements. IIS can require SSL for entire sites or specific folders. URL rewriting can be configured through the URL rewrite module. This allows transforming URLs before they're processed, useful for friendly URLs, canonicalization, or redirects. Compression reduces bandwidth by gzip or deflate compressing responses. Static compression caches compressed versions of files. Dynamic compression compresses generated content on the fly. Failed request tracing helps diagnose problems by logging detailed information about requests that fail or take too long. You configure rules for which requests to trace and what information to capture. For interviews, be prepared to explain the relationship between IIS and ASP.NET, what application pools are and why they matter, how requests flow from IIS to your application code, and common configuration scenarios like SSL and URL rewriting. Chapter 12: Caching and Performance. Performance is always a concern for web applications, and caching is one of the most effective techniques for improving it. ASP.NET provides several caching mechanisms at different levels. Output caching stores the complete rendered output of pages or user controls. When a cached page is requested, ASP.NET serves the cached HTML without executing any page code. This is incredibly efficient for pages that don't change frequently. You enable output caching with the output cache directive at the top of your page. The duration attribute specifies how many seconds to cache. The vary_by_param attribute determines whether different cached versions are stored based on query string or form parameters. Vary_by_header and vary_by_custom provide additional variation options. Fragment caching, using output caching on user controls, lets you cache portions of a page while leaving other portions dynamic. This is useful when a page has both static and dynamic sections. Output caching can store responses in memory on the web server or in distributed caches. Cache profiles in web.config let you define caching settings centrally and reference them by name. The Cache API provides programmatic access to a flexible object cache. You store objects with cache. Insert, or the indexer, specifying expiration policies and dependencies. Cached objects automatically expire based on absolute time, sliding time since last access, or changes to files or other cached items. Cache dependencies are powerful. You can create a cache entry that expires when a file changes, when another cache entry changes, or when a SQL query returns different results. SQL cache dependency integrates with SQL Server to invalidate cache entries when underlying data changes. Data source controls have built-in caching. SQL data source can cache query results, automatically invalidating when parameters change. This reduces database load for frequently executed queries. Beyond caching, there are many performance considerations for web forms applications. View state size directly impacts performance. Large view state increases bandwidth, slows page loads, and increases server processing time for serialization and deserialization. Audit your pages to identify unnecessary view state and disable it where possible. Session state can impact both performance and scalability. In-process session state doesn't scale beyond a single server. Out-of-process session state adds network overhead. Store only what you need in session. And consider alternatives like cookies or database storage for data that doesn't truly need session semantics. Database access is often the primary bottleneck. Use parameterized queries or stored procedures. Consider connection pooling settings. Profile your queries and optimize the slow ones. Consider an ORM with efficient patterns or careful use of raw SQL. Reduce HTTP requests by combining CSS and JavaScript files, using CSS sprites for images, and leveraging browser caching. ASP.NET has bundling and minification features that help with this. Enable compression in IIS for text-based responses. The CPU cost of compression is usually far outweighed by the bandwidth savings. Use asynchronous operations for I/O-bound work. Async pages and handlers let worker threads return to the pool while waiting for database queries or service calls, improving overall throughput. Consider a content delivery network for static resources. CDNs serve files from edge locations close to users, reducing latency. For interviews, be prepared to discuss output caching configuration, the cache API and dependencies, view state optimization, and general web performance principles. Chapter 13. Error Handling and Diagnostics. Robust error handling is essential for production applications. ASP.NET provides several mechanisms for handling and logging errors. At the page level, you can handle exceptions in try-catch blocks around specific code. The page error event fires when an unhandled exception occurs on the page, giving you a chance to log it or take corrective action. At the application level, application error in global. ASAX fires for any unhandled exception. This is a common place to implement centralized error logging. You can access the exception through server, get last error, log it, and optionally clear it with server. Clear error to prevent the default error page. The custom errors configuration in web, config controls what users see when errors occur. In mode equals remote only or on, users see friendly error pages instead of detailed exception information. You can configure a default error page and specific pages for different HTTP status codes. Health monitoring is a comprehensive framework for logging events, including errors, lifetime events, request processing events, and security events. You configure event providers in web.config to specify which events to log and where to log them. Event log, SQL Server, email, WMI, or custom providers. Tracing provides detailed diagnostic information about page execution. Enable tracing with the trace directive or in web.config. Trace output shows the control tree, session state, request details, and timing information for each phase of the page lifecycle. You can write your own trace messages with trace. Write or trace. Warn. Failed request tracing in IIS captures detailed logs for requests that fail or take too long. You configure rules specifying which requests to trace by URL, status code, or time taken, and IIS generates XML logs with complete request details. Logging frameworks like Log4net, nlog, or the built-in system. Diagnostics provides structured logging throughout your application. Configure different log levels, outputs, and formats. Include contextual information like user identity, request URL, and correlation IDs. Performance counters expose runtime statistics that can be monitored with Windows tools. ASP.NET exposes counters for request rates, request queue length, errors, cache hit ratios, and more. IIS exposes additional counters for connections, bandwidth, and process statistics. For debugging, remote debugging lets you attach Visual Studio to a running application. Configure the remote debugger on the server and attach from your development machine. This is invaluable for diagnosing issues that only occur in production environments. IntelliTrace in Visual Studio Enterprise can record application execution for playback later. This is useful for capturing the state at the moment an error occurred. For interviews, be prepared to explain the error handling hierarchy from page to application level, custom error page configuration, health monitoring concepts, and tracing capabilities. Chapter 14. Deployment and Configuration. Deploying web forms applications involves several considerations. Let's cover the key aspects of deployment and configuration management. Web.config is the primary configuration file. It's XML-based and hierarchical. Settings in child directories override settings from parent directories. The root configuration is machine. Config in the .NET Framework directory. Common configuration sections include connection strings for database connections, app settings for custom key-value settings, system-wide for ASP, net-specific settings, and system. Web server for IIS settings in integrated mode. Configuration can be encrypted to protect sensitive data like connection strings. The ASP.NET Eregius tool encrypts specified sections using Windows Data Protection API or RSA encryption. The application decrypts automatically at runtime. Configuration transforms. Using web.config transformation syntax, modify configuration for different environments during deployment. You create transform files like web, release.config with modifications to apply, replacing connection strings, removing debug attributes, adding production settings. Publishing from Visual Studio packages your application for deployment. You can publish to a folder, FTP, or directly to IIS via web deploy. Publish profiles store deployment settings for consistent, repeatable deployments. Web deploy, also known as MS deploy, is a powerful deployment technology. It can deploy to IIS directly, synchronize content between servers, deploy databases, and more. It supports parameterization for environment-specific values. IIS deployment involves creating the site, application pool, and virtual directories in IIS Manager or through command line tools. You copy your application files to the deployment directory and configure any required IIS settings. For production deployments, consider automated deployment pipelines. Build servers compile and package the application. Deployment tools push packages to staging and production environments. Configuration management ensures each environment has appropriate settings. Precompilation improves startup performance by compiling pages ahead of time rather than on first request. The ASP.NET compiler tool generates assemblies from your pages. This also catches compile errors before deployment. Bin deployment versus GAC deployment affects how assemblies are located. Assemblies in the bin folder are application-specific. Assemblies in the global assembly cache are shared across applications. Most application assemblies belong in bin. Framework extensions might go in the GAC. For interviews, be prepared to discuss configuration file structure and precedence, connection string encryption, configuration transforms for different environments, and deployment options. Chapter 15. Common Interview Questions and Answers. Let's wrap up with a rapid-fire review of common interview questions and how to approach them. What is the ASP.NET page lifecycle? Walk through the key events: init, load view state, load postback data, load, raise postback events, pre-render, save view state, render, unload. Emphasize understanding of when view state is available and when to create dynamic controls. What is view state and how does it work? Explain that it's a mechanism for persisting control state across postbacks, implemented as a hidden form field containing serialized state. Discuss when it's useful and the performance implications. What is the difference between session and view state? Session persists across page navigations and is stored on the server. View state only persists across postbacks on the same page and is stored in a hidden field sent to the client. What are the different session state modes? In process, state server, SQL server, and custom. Explain the trade-offs between performance and scalability. Explain the difference between server, transfer, and response. Redirect. Transfer happens on the server without a client round trip. The URL in the browser doesn't change. Redirect sends an HTTP redirect response, causing the browser to make a new request. The URL updates. What is the difference between authentication and authorization? Authentication identifies who the user is. Authorization determines what the user can do. Authentication comes first. What are HTTP handlers and HTTP modules? Handlers process specific requests and generate responses. Modules participate in the pipeline for all requests, handling cross-cutting concerns like logging or authentication. What is the GAC? The Global Assembly Cache is a machine-wide code cache for assemblies shared across applications. Assemblies must be strong-named to be installed in the GAC. How do you implement caching in ASP.NET? Output caching for pages and controls with the Output Cache directive, the Cache API for programmatic object caching, data source control caching for query results. What is the difference between user controls and custom controls? User controls have ASCX markup files and are easier to create. Custom controls are compiled into assemblies and are more reusable across applications. How would you improve the performance of an ASP.NET application? Reduce view state, implement caching at multiple levels, optimize database queries, minimize HTTP requests, enable compression, use async for I/O-bound work. What is the difference between classic and integrated mode in IIS? Classic mode runs ASP.NET as an ISAPI extension with a separate pipeline. Integrated mode unifies IIS and ASP.NET pipelines, allowing modules to participate in all requests. What is WCF? Windows Communication Foundation is a unified framework for service-oriented applications, combining capabilities previously spread across ASMX, remoting, and MSMQ. Explain the ABC. Address, binding, contract. What are the advantages of WCF over ASMX web services? Multiple transports and protocols beyond HTTP and SOAP, more robust security options, better support for interoperability standards, flexible hosting options. These questions represent the fundamentals that any experienced web forms developer should be comfortable with. Practice explaining them clearly and concisely, and be ready to dive deeper when the interviewer follows up. Chapter 16: Practical Wisdom and War Stories. Before we wrap up, let me share some practical wisdom that comes from working with these technologies in the real world. This is the kind of knowledge that doesn't fit neatly into documentation, but makes all the difference when you're building and maintaining actual applications. First, on debugging view state issues. When something isn't persisting correctly across postbacks, the problem is almost always lifecycle related. Either you're creating dynamic controls too late, or you're setting values after view state has been saved, or you're checking values before view state has loaded. The fix is always the same. Trace through the lifecycle and figure out when your code is running relative to the view state phases. I've seen developers spend hours convinced there was some mysterious bug when the answer was simply moving their control creation from page load to page init. On session state gotchas, here's one that bites people regularly. Session state in ASP.NET has an exclusive lock by default. When a request accesses session state, other requests from the same session block. This can cause mysterious slowdowns when you have multiple AJAX requests or when you're opening pages in multiple tabs. The fix is to mark pages that only read session state with the enable session state equals read only directive, or disable session state entirely for pages that don't need it. On WCF debugging, the most useful thing you can do is enable WCF tracing. Add system, service model, and system. Service model, message logging to your trace sources in web. Config, configure a listener, and you'll get detailed logs of what's happening in your service. When a client can't connect or you're getting mysterious faults, the trace logs usually reveal the problem immediately. Binding mismatches, security configuration issues, serialization failures. Without traces, you're flying blind. On IIS troubleshooting, remember that IIS keeps its own logs. The logs in the log files directory under inetpub show every request with status codes, time taken, and other details. When users report errors and your application logs don't show anything, the IIS logs often reveal what's happening. Maybe the request never reached your application because of a configuration issue or authentication failure. On connection string management, never hardcode connection strings. Always use the connection strings configuration section. Use SQL Connection String Builder when you need to construct connection strings programmatically. Enable connection pooling, it's on by default, and understand that pooling is per unique connection string, so slight variations create separate pools. On the transition to modern technologies, if you're maintaining a web forms application and considering modernization, The path isn't always a complete rewrite. You can add Web API controllers alongside web forms pages for new functionality. You can gradually migrate to MVC views while keeping web forms for complex existing pages. You can introduce modern JavaScript frameworks for the front end while keeping server-rendered pages for simpler scenarios. The pragmatic approach is incremental improvement rather than big bang rewrites that often fail. And finally, on presenting your experience in interviews. When asked about web forms, don't be defensive about working with older technology. Frame it positively. You understand web fundamentals deeply. You can maintain and extend legacy systems, and you've seen how frameworks evolve over time. The architectural patterns, separation of concerns, state management, caching, security transcend any particular framework. Your web forms experience gives you perspective that developers who've only used modern frameworks might lack. Appendix. Quick reference glossary. Let me close with a rapid glossary of terms you might encounter. These are quick definitions you can use for mental recall before interviews. ASEXX, the file extension for web forms pages, contains declarative markup and references a code behind file. Code behind, the C# or VB.NET class file paired with an ASPX page, contains the procedural logic for the page. Postback, when a page submits to itself. These postback property distinguishes first loads from subsequent submissions. Auto postback, a control property that causes immediate postback when the control's value changes, rather than waiting for a button click. Runout server, the attribute that makes an HTML element a server control, giving it server-side programmable properties and events. Master page, a template page that defines common layout shared by multiple content pages. Content page, a page that uses a master page and injects content into the master's placeholders. ASTX, the file extension for user controls, which are reusable page fragments. A special folder for code files that get compiled automatically by ASP.NET. A special folder for data files like databases, typically given restricted IIS access. The file extension for traditional ASP.NET XML web services predating WCF. Global, SX. The application file containing event handlers for application-level events, like start, end, and error. Machine. Config, the root configuration file for all .NET applications on a machine. HTTP handler, a component that processes requests for specific URLs or extensions and generates responses. HTTP module, a component that participates in the request pipeline for all requests, handling cross-cutting concerns. Internet Server API, the native IIS extension interface that ASP.NET Classic Mode uses. W3 WP DXE, the IIS worker process executable that hosts ASP.NET applications. ASP.NET SNET, a command line tool for registering ASP.NET with IIS and managing configuration encryption. A command line tool for generating WCF client proxies from service metadata. Web Services Description Language, the XML format describing web service interfaces. Simple Object Access Protocol, the XML-based messaging protocol used by ASMX and WCF basic HTTP binding. Representational State Transfer, the architectural style emphasizing resources and HTTP verbs, commonly used with Web API as an alternative to SOAP services. Endpoint. In WCF, the combination of address, binding, and contract that defines where and how a service can be accessed. Fault contract. In WCF, a contract specifying the error information a service operation can return to clients. Strong name, an assembly identity consisting of name, version, culture, and public key required for GAC installation. Global assembly cache, the machine-wide store for shared assemblies. Precompilation, compiling ASPX pages before deployment rather than on first request, improving startup time. WebGarden, an IIS configuration where multiple worker processes serve a single application pool, enabling CPU-level parallelism. WebFarm, Multiple web servers working together to serve a single application, requiring shared session state and synchronized configuration. Conclusion. We've covered a lot of ground in this audiobook. From the philosophy behind web forms to the details of the page lifecycle, from view state mechanics to state management options, from server controls to data binding, from master pages to authentication, from the HTTP pipeline to WCF, from IIS architecture to caching strategies, you now have a comprehensive refresher on the technologies you once knew well. The key to interviews is not just knowing the facts, but being able to articulate them clearly and connect them to real-world scenarios. When you're asked about view state, don't just recite the definition. Explain when it's useful, when it's problematic, and how to manage it effectively. When discussing the page lifecycle, demonstrate that you understand why the order matters by giving examples of what goes wrong when code runs at the wrong time. Web forms may not be the cutting edge of web development anymore, but it remains in production in countless enterprise applications. Understanding it deeply shows that you can work with mature code bases and that you have the foundational knowledge that applies to all web development, regardless of the specific framework. Good luck with your interviews. Remember, you already know this stuff. The concepts are just waiting to be reactivated. Go show them what 12 years of experience looks like. End of audiobook. Total word count, approximately 10,000 words. Estimated reading time, 45 to 60 minutes. Estimated listening time at 1x speed, 60 to 75 minutes.